This is Gabrick here again today for Variations on a Theme. If you turn in your packets to the note sheet that says Variation on a Theme, you'll be able to take notes with me as we go through this. Alright, so think about this. If a homozygous white butterfly is crossed with a homozygous dark blue butterfly, what outcome would you predict in the offspring? So think about that. If white is dominant, hopefully you're predicting that all the offspring would be white. If dark blue is dominant, you may then be thinking that all the offspring would be dark blue. Okay? But in this particular instance, we don't see either of those in the offspring. What we see is that they're all light blue. Why? In this case, neither allele is truly dominant. And the offspring end up being a blend of two traits, or, in this case, light blue. So let's see how we would write this trait, okay? So for this cross, we're going to use slightly different symbols. In butterflies, we're going to use big W for wing, and then we're going to put on it what the allele is. So if the allele is white, we're going to write W as a superscript. If it's dark blue, we're going to write B, okay? So again, this just means one allele can be white, WW, or an allele can be dark blue, WB. So if we cross a homozygous white butterfly with a dark blue butterfly, how would we set this problem up? Alright, so our P generation remember our pure parental generation, it's homozygous white, so both alleles have to be for white. The dark blue butterfly is homozygous, both alleles are for blue. So we write it that way. We're still going to show what type of sex cells they can make because they're both the same. The white butterfly can only make WW, and the blue butterfly can only make WB, WB. Now at this point, you might be to the point where you can say, I don't need to do a Punnett square, and that's great. Don't do it if you don't need to. But if you're still feeling like you'd be a little more comfortable if you did, go ahead and put the alleles for the blue butterfly across the top, alleles for the white on the side, and then as you can see, the only thing we can get are heterozygous butterflies that are WW, WB. Now, if I'm going a little too fast, at any time and you're taking notes, which you should be, just pause this and catch up. Alright, so take a look at that, and let's move up a little bit. So looking at our Punnett square, the genotype and ratio of the F1, they are all WW, WB. Again, if you prefer doing it actually as a ratio, you could say 0, WW, WW, to 1 or 4, whichever you prefer, WW, WB, to 0, WB, WB. I always reduce mine, that's just because that's the way I learn. What's the phenotype in the ratio of the F1? Well, they're all light blue. Or again, if you prefer to write it out, you could say 0 dark blue to 1 light blue to 0 white. Remember, don't just write 0 to 1 to 0 or 1 to 0 to 0. Make sure you tell me what the 0 is. 0 dark blue, 1 light blue, 0 white. Now we're going to cross two F1 butterflies. Since our F1 was all WW, WB, we're going to cross it with one of its siblings, and that's our cross. Once again, Mendel's law of segregation said we separate the two homologous chromosomes, the two alleles, and that means we have one egg that gets WW and one that's going to get WB. Sperm, one sperm's going to get WW, the other one is going to get WB. Now for this one, you probably do want to do a Punnett square. So I put the sex cells of one across the top, the sex cells of the other, the sex cells of the other down the side. Go ahead and pause, fill this in, and then in a couple minutes come back and check and see if you got it right. Okay, well, if you did it right, you ended up with WW, WWWB, WWWB, WB, WB. And your ratios should have been 1. And you don't have to do them in the same order that I'm doing them. And you can have 1 WW, WW to 2 WW, WB to 1 WB, WB. Or you could say 2 WW, WBs to 1 WW, WW to 1 WB, WB. Any of those would be fine. Phenotype and ratio of the F2, 1 white to 2 light blue to 1 dark blue. Cool thing about these problems is the ratio of both the genotype and phenotype will be the same, 1 to 2 to 1. Okay, so now quick review. What's the genotype of a dark blue butterfly? Hopefully you said WB, WB. A white butterfly? Hopefully you thought WW, WW. And a light blue butterfly? WW, WB. Got all those right? Great. So, this is the law of incomplete dominance, and what it says is that the F1 produces a phenotype quantitatively intermediate between the two homozygous parents. Okay? So the F1, and maybe instead of produces, a better word would be expresses. A phenotype, quantitatively intermediate. It's halfway in between. So if you think about that for the next problem, in certain flowers, the allele for red flowers is incompletely dominant with the allele for white flowers. Critical here that you see incompletely dominant. I would underline that when I'm doing the problem, because that means we do it different than just being a dominant problem. We're going to use FR as the allele for red flowers. F is going to be for flowers. So white flowers will be FW. So we're going to cross a white flower and a red flower. That's going to be our P generation, because they have to be homozygous to be red and white. And then we're going to figure out the genotypic and phenotypic ratios for the F1 and F2. Alright, so a white flower, FW, FW. The red flower, FR, FR. And now if I were you, I'd go ahead and pause this, and you go ahead and figure out the genotypic and phenotypic ratios for the F1 and F2. When you're done, come back, and I will have the answers done for you. Alright, so hit pause. Alright, welcome back. I'm going to go ahead and do this very quickly. My P generation can only make FW sex cells. This one can only make FR. I don't need to do a Punnett square for this one, because I'm going to get my F1 is going to be all FW, FR. Whoops. Alright. That's my genotypic ratio, and they will all be halfway in between. To do my F2, I'm going to cross FW, FR, cross with FW, FR, FW sex cells, or FR sex cells for both of these parents. And for that one, I do want to do a Punnett square. Put one parent across the top, one parent sex cells down the side. I've got an FR, or red. I've got an FW, FR for pink, and FW, FR pink, and FW, FW white. Let's see, so that means my genotypic ratio is going to be 1 FR to 2 FW, FR to 1 FW, FW. And again, you can say 2 FW, FR to 1 FW, FW to 1 FR, FR. That's fine. My phenotypic ratio will be 1 red to 2 pink to 1 white. Again, displaying the law of incomplete balance. We have something in between the two of them.